In the earlier videos, we have learned about trigonometric equations. Now, let us learn inverse trigonometric functions. Some of the important points in trigonometric functions, inverse trigonometric functions are: if sin x is equal to sin theta is equal to x and theta belongs to minus pi by 2 and pi by 2, then sin inverse x is equal to theta. Similarly, if cos theta is equal to x and theta belongs to 0 and pi, then cos inverse x is equal to theta. And again, if tan theta is equal to x and theta belongs to minus pi by 2 and pi by 2, then tan inverse x is equal to theta. If cot theta is equal to x and theta is belongs to 0 and pi, then cot inverse x is equal to theta. If secant theta is equal to x and theta belongs to 0 and pi by 2, union pi by 2 and pi, then secant inverse x is equal to theta. Similarly, if cosecant theta is equal to x and theta belongs to minus pi by 2 and 0, union 0 and pi by 2, then cosecant inverse x is equal to theta. And some more other functions are: sin inverse x plus cos inverse x is equal to pi by 2 if x is less than or equal to 1, that is minus 1 less than or equal to x less than or equal to 1. And similarly, tan inverse x plus cot inverse x is equal to pi by 2 for any x belonging to R. Secant inverse x plus cosecant inverse x is equal to pi by 2 if x belongs to minus infinity minus 1 union plus 1 unit and infinity. And we will see some functions and domain and range of some of the values. If sin inverse x, the domain is minus 1 and the range is minus pi by 2 and pi by 2. Similarly, cos inverse x is equal to minus 1 and 0 pi by 2, and the other domains are tan inverse x, cot inverse x, secant inverse x and cosecant inverse x. So we have seen the function, the domain and the range. Let us learn some more formulae or important points in this chapter before doing some examples. Now let us see some more important points. Principal value for sin inverse x, tan inverse x, cot inverse x, cosecant inverse x. The principal value lies between minus pi by 2 and pi by 2. Similarly, for cosecant inverse x and secant inverse x, the principal value lies between 0 and pi. And tan inverse x plus tan inverse y is equal to tan inverse x plus y by 1 minus xy if xy is less than 1 and x is greater than 0 and y is greater than 0. Similarly, tan inverse x minus tan inverse y is equal to tan inverse x minus y by 1 plus xy. If x and y belongs to 0 and x square plus y square is less than or equal to 1, then sin x minus sin y is equal to sin inverse, sin x minus sin y is equal to sin inverse x into root over 1 minus y square plus y into root over 1 minus x square. Similarly, if x and y belongs to 0 and 1 and x square plus y square is greater than 1, then sin inverse x plus sin inverse y is equal to pi minus sin inverse x into root over 1 plus 1 minus y square and plus y into 1 minus x square. Similarly, if x and y belongs to 0 and 1, then sin inverse x plus sin inverse y is equal to cos inverse 1 minus x square under root into 1 minus y square under root minus xy. If x and y belongs to 0 and 1, then sin inverse x minus sin inverse y is equal to sin inverse x minus root over 1 minus y square minus y into root over 1 minus x square. If if 0 less than or equal to y less than or equal to x less than or equal to 1, then sine inverse x minus sine inverse y is cos inverse root over 1 minus x square minus 1 by x square plus xy. If x and y belongs to 0 and 1, then cos inverse plus cos inverse x plus cos inverse y is x plus y minus 1 minus x square and 1 minus y square. Similarly, we have the other values for cos inverse x and cos inverse y, and cos inverse x minus cos inverse y, and cos inverse x minus cos inverse y when x and y belongs to 0 and 1. We have some more important points to be noted, and after seeing them we can solve some examples which will make us understand the inverse trigonometric functions with much more clarity. If tan inverse x plus tan inverse y plus tan inverse z is x plus y plus z minus xyz by 1 minus xy minus yz minus zx, if x, y, z have the same sign and xy plus yz plus zx is less than 1, 2 sin inverse x is equal to sin inverse 2x into root over 1 minus x square if x is less than or equal to 1 by root 2. Similarly, 2 cos inverse x is equal to cos inverse 2x into 2x square minus 1 if x is greater than or equal to 1 by root 2. 2 tan inverse x is equal to tan inverse 2x by 1 minus x square if x is less than 1. 2 tan inverse x can also be written as sin inverse 2x by 1 plus x square, that or cos inverse 1 minus x square by 1 plus x square if x is greater than or equal to 0, and minus cos inverse 1 minus x square by 1 plus x square if x is less than 0, and tan inverse x by tan inverse x into 2x by 1 minus x square. Similarly, 3 sin x is equal to sin inverse 3x minus 4x cube for x for 0 less than or equal to x less than or equal to half. Similarly, 3 cos inverse x is equal to cos inverse 4x cube minus 3x for root 3 by 2 less than or equal to x less than or equal to 1. Tan inverse x is 3 tan inverse x is equal to tan inverse x 3x minus x cube by 1 minus 3x square for 0 less than or equal to x less than or equal to 1 by root 3. We have covered almost all the important points in this chapter. Let us start doing some examples to understand the subject of trigonometric equations, inverse trigonometrical equations thoroughly. Some examples. Sin inverse minus root 3 by 2, that is minus sin inverse root 3 by 2, that is minus sin inverse sin of pi by 3, which is equal to minus pi by 3. Since sin inverse minus x is equal to minus sin inverse x if x belongs to minus 1 and 1. Similarly, sin inverse sin theta is theta if theta belongs to minus pi by 2 and pi by 2. Let us see another example. Cos inverse into cos inverse 1 by root 2, which is nothing but cos inverse cos pi by 4, which is pi by 4. Now secant inverse root 2, which is pi minus secant inverse root 2. The value of secant root 2 is secant pi by 4. Therefore, pi minus secant inverse pi by 4, which is equal to pi minus pi by 4, which is 3 pi by 4. Let us see another example. Cot inverse minus root 3. That is cot inverse cot inverse minus root 3 is nothing but pi minus cot inverse root 3, which is pi minus cot inverse cot pi by 6, which is pi minus pi by 6 or 5 pi by 6. Similarly, cos inverse cos of 5 pi by 4. Cos inverse cos of 5 pi by 4 can be written as pi plus pi by 4, pi plus pi by 4. Cos inverse minus cos pi by 4, that is pi minus cos inverse cos pi by 4, which is pi minus pi by 4, which is 3 pi by 4. Prove that sin inverse 3 by 5 plus sin inverse 8 by 17 is equal to cos inverse 35 by 85. This problem can be done in two methods. Let us see the method 1. That is, let sin inverse minus 3 sin inverse 3 by 5 be alpha and sin inverse 8 by 17 be beta. Then sin alpha is 3 by 5, sin beta is 8 by 17, and alpha and beta it belongs to 0 and pi by 2, so that cos alpha is equal to 4 by 5 and cos beta is 15 by 17. Now let us see what is cos of alpha plus beta. Cos of alpha plus beta is nothing but cos alpha cos beta minus sin alpha sin beta, that is 4 by 5 into 15 by 17 minus 3 by 5 into 8 by 17, which is 36 by 85, which is greater than 0. Therefore, hence alpha plus beta is equal to 0 and pi by 2. Alpha plus beta is nothing but cos inverse 36 by 85. Let us see how this can be done in the second method. We know that sin inverse x plus sin inverse y is equal to sin inverse x into 1 minus y square plus y into 1 minus x square if x and y belongs to 0 and 1 and x square plus y square is less than 1. That is, in the similar representation, cos inverse will be 1 minus x square under root into 1 minus y square minus xy if x and y belongs to 0 and 1. Therefore, sin inverse 3 by 5 plus sin inverse 8 by 17 is nothing but cos inverse 1 minus 3 by 5 whole square over root and root over 1 minus 8 by 17 whole square minus xy is nothing but 3 by 5 into 18 by 70, 8 by 17. Therefore, cos inverse 4 by 5 into 15 by 17 minus 24 by 85, that is nothing but cos inverse 36 by 85. That is the required thing to be proved. Given sin of cos minus cos inverse 3 by 5 plus cos inverse 12 by 13, find the value of sin of cos inverse 3 by 5 plus cos inverse 12 by 13. Let cos inverse 3 by 5 be alpha and cos inverse 12 by 13 be beta. Therefore, cos alpha will be 3 by 5 and cos beta will be 12 by 13, so that sin alpha is equal to 4 by 5 and sin beta is 5 by 13. Now, sin of cos inverse 3 by 5 plus cos inverse 12 by 30 is nothing but sin of alpha plus beta, just substituting the values as we have assumed that cos inverse 3 by 5 is alpha and cos inverse 12 by 13 is beta. Therefore, sine of alpha plus beta is nothing but sine alpha cos beta plus cos alpha sine beta, which is 4 by 5 into 12 by 13 plus 3 by 5 into 5 by 13, which is 63 by 65. Similarly, let us see another example. Show that secant square into tan inverse 2 plus cosecant square into cot inverse 2 is equal to 10. Let tan inverse 2 be alpha and cot inverse 2 be beta. Therefore, tan alpha will be 2 and cot beta is equal to 2. Secant square into tan inverse 2 plus cosecant square into cot inverse 2 is nothing but putting the value of tan inverse 2 as alpha and cot inverse 2 as beta. We have secant square alpha plus cosecant square beta. Secant square alpha is 1 plus tan square alpha and cosecant square is 1 plus cot square beta. Substituting the value of tan alpha as 2, you get 1 plus 4 into 1 plus 4 into 1 plus 4, which is 5 plus 5, which is 10, which is the required RHS. Now, on doing this assignment, you will be able to understand the inverse trigonometric functions which has been taught with certain examples in a more explicit and clear manner. So, evaluate the following, and on completion you will be able to get idea about the inverse trigonometric functions, and in case of any doubts you can even subscribe to my channel or look into my blog for any enquiries or any of the problems which has been given in the assignment for solutions. In the next few videos, we shall learn more about the inverse trigonometric functions and with some more examples which will clearly make you understand the subject.